search for the whole thing. So like I said, there's the top half. You guys ready for the bottom half? Okay. Test Thursday. Okay, so I'm going to go fill up my water bottle while you're checking the bottom half.
I feel like I have segmented grasp.
Okay. I said I would read 16, 18, and 20 because of that changed assignment thing, so let me do that. 16 would be a horizontal flip, and horizontally compressed, half as wide. 18, vertical flip, and it's half as tall. 20, that I won't try and trip you up with that right now, but it technically would be a horizontal flip. We got that, but it would actually be 4/3 times wider because it's 3/4. You do the reciprocal of that, it'd be 4/3 times wider. So it's a stretch by 4/3. We have a test on Thursday. The things I think are going to give you grief are some of the things we're going to review today from this section and your piecewise functions. So again, we're practicing piecewise functions every day. So we make sure and see that we can do a great job. So, what do you have questions on? You should, hopefully you'd have a couple questions. If there's no questions, I mean, I'm not challenging you. Yeah, sure. Okay. So let me zoom in on this. I am recording, so I got to remember not to be too big a goofball, I suppose. Okay, so here we go. First thing I did, I said x is less than 3, so I chopped it up, wrote that equation right here. So I know what to plug it into in that section. This middle part, 4, or 0x plus 4, from -3 to 1, so I wrote that down. Greater than 1, x plus 2, I wrote that down. Okay? So, to know where this section here, where that's going to start, or where it's going to end, you can look at it either way. I plugged in -3. So if I plug in -3 right here, -3 times -2 gives me 6, plus 3 gives me 9. So that's way up at 9. Open circle because of that. And then from there, my slope is -2, so it should be downhill, going to hit that. So I went up 2 over 1 to the left, so it would be a negative slope. And one thing you can take a look at too is if I keep going, does it look like it would hit at 3? Yeah, I shouldn't keep going because I can only do it in that section, but it gives me some idea that I probably did that part right. This next part, my answer is 4. So it's just going to be 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. Or if you don't like that and you want a slope, you can write as 0x plus 4. So my slope is 0. It's flat. It has a y-intercept at 4. And then 1, 3. Well, okay. To know where it starts here, I plugged in 1. And I found out it would have been 3 high. Open circle, because that's where it terminates. And then from there, it's going to have a slope of 1, so up 1 over 1, up 1 over 1, up 1 over 1. Did I answer your question? Okay. Today, I'm going to ask you to do one more, and I'm going to ask you to do one where you have to write the equation. So I'm going to ask you to do that on Thursday. Great question. What else? Volleyball plays Takema tonight, is that right? Okay, what's their record, do you know? Okay. They're good?
That's what I've heard.
Okay. That one, I'll tell you what, don't worry about that. Don't worry about it. But if you think about it, if I did something like this, we'll talk about it just a little bit, but I'm just saying don't lose sleep over it. So if I had y equals, let's go 2x squared. Well, okay, let's get to where this is. And so we agree that that would be a shrink times 1/2. Half as wide. Why? Because we just flipped that over. It's going to be the reciprocal. It's always going to be the reciprocal. It just so happens that the ones we've dealt with so far, the reciprocal's been pretty easy. Okay? So this one, 2x, I can plug in something that's half as big and still get the same result, so it's going to be half as wide. But if I do something like y equals 1/4 x quantity squared, well, that's going to, since it's the opposite, it's going to make it 4 times wider. Okay? So where does that come from? The fact that we did the reciprocal of 1/4 is 4 times as wide. Okay? But if on this situation where it was like -3/4 on the inside of something, whether it be absolute value or squaring, then it would be 4/3. And since that's less than 1, my multiplier is going to be bigger than 1, so it actually is a little bit of a stretch. But that's not my goal to get that picky at this point. In my opinion, they're throwing way too many high-level conceptual things early in the text, and they might want to wait till a little bit later. Okay? Like the next section, you're going to be like, geez, we should have done this earlier. Or the next chapter. But anyway. Okay. Anything else? Let's go. Grab a sheet. And somebody give me one, please. Thank you, sir. I just threw a bunch of stuff on a worksheet. First of all, a sheet without all of these equations on it, I did make 100 copies of that, so it has all the axes and stuff on it. If you want to grab one at some point in time, you can. And I also want to say you don't need a fresh sheet of graph paper for each assignment. If on one assignment you only have 2 graphs, Well, you can save this graph paper and then just do a couple more for the next one. As long as your graphs are somewhere I can find them, you can show them to me. I'm okay with that. Just do your regular stuff on regular paper, and then, a graph, pull out your graph paper that's half used up, and then do a couple more. Okay? It's no big deal. Okay? But today, this is kind of out of order because I just threw a bunch of stuff down that I thought we might need based upon how, some of the finer points from yesterday. Okay. Excuse me. Very rude for me to yawn like that, but oops, sorry. Okay, let's do the one in the middle of the second row. Okay. -3 times quantity x minus 1 squared plus 5. Okay. Where should I start? Where's my vertex on this one going to be? Right 1 up 5. So 1, 5. 1, 1, 2, 3, 4, 5. Okay. And just so I can kind of get my bearings, I'm going to put my axis of symmetry so I can go ahead and reflect points on either side. Sorry, I'm still trying to figure out what the best way to get this thing, the white balance right. Anyway, okay, this one going to open up or down? Down. It's been vertically reflected because of the negative outside. And this one, vertically, does it get stretched or does it get compressed? Yeah, it gets stretched. It's 3 times as tall. It's outside, so it's going to do exactly what you think. So here's what we could do. Just a little review. Is our normal one, we would go out 1, down 1, out 2, down 4. Why? Because 1 squared is 1 and 2 squared is 4. I could go over 1, down 1, over 2, down 4, or I could reflect it over my axis. And this one, due to that 3, is going to be 3 times taller. Its movement vertically is going to be 3 times the movement it had before. So we'll just do it 3 times as much. Here I went over 1, down 1, but here on this one I need to go down 3 on both sides. On my next one, it was over 2, down 4. Now I'm going to have to go 3 times that much due to that magnification factor of my vertical. So instead of down 4, I'm going to go down 12. And if I have my line of symmetry drawn, I can see that it's over here. There we go. So you can see that from my orange points, it used to be down 4, but now it's down 12. 3 times as much. 3 times as much. Okay? So with that in mind, let's have you do one on your own. Let's do this 1/2 x plus 1 squared minus 3. Let's have you guys do that one on your own. And while you're doing that, I will do my attendance. I know we've got a lot gone. So usually I have 15, 5, 10. We've got 4 gone. 1, 2, 3, 4. Okay. So I'm going to do this for you. -1, -3. This one going to open up or down? Up. We usually go over 1 up 1, but in this case it's going to be half as tall, so we'll go over 1 up a half. We usually go over 2 and up 4, but in this case we're just going to go up 2. So everything's half as tall as it usually is. There is a way you could get other points on it if you need to. If you absolutely needed to, you could ask yourself, 1, how high is it? By plugging in 1. If I plug in 1, 1 plus 1 is 2. Squared gives me 4. Half of that is 2. 2 minus 3 gives me -1. So realize you can always do that. That will work all the time. If you ever are like, I don't know how high this is going to be, plug something in, and it'll tell you how high it's going to be. Okay? Okay.
Why if we plugged in 2 did you get out 2 there?
Why did I plug? If I get 2, I get out 2.
If you go over 2 and up 2.
Well, because where am I at on my graph? I'm 1 below.
Oh, okay.
So my point is that even though from my vertex I went over 2 and up 2, I'm still 1 below my x-axis.
Okay.
This is all in relationship to my vertex. Yep. Because it hasn't been flipped. It hasn't been reflected. Okay. So now what I want to do is I want to go to what I would consider the most challenging part of this section is figuring out the equation. Okay, because now we're going backwards. That requires a higher level of understanding. Let's go to the middle one on the top. Let's find the equation of that. First of all, we know it's an absolute value function. Okay. Now I've just got to plug in my stuff. So it'll cause a slide to the left of 4, a rise of 4, and then the slope the way it should be. Okay? So what should I have in the inside? X to get it to go to the left 4. Is it -4 or +4? +4 is always the opposite. If it's inside, it causes horizontal changes, and it's going to be the opposite of what you think. Now, hopefully we understand why, because now we can plug in smaller values, and we'll still get the same heights, because it's adding 4. What do I need on the outside? -4? -4 would move it down. It needs to be +4. The inside's the opposite. The outside is exactly what you think. So now your absolute value, your slope, is your growth factor vertically. So if we look at this right side, it's always the right side, all we got to do is find the slope. And that'll give us our A value out front.
It'd be 2/3.
Yep, 2/3. And that's it. That is definitely going to be on the quiz, to be able to write functions for certain graphs. So with that in mind, let's do the other absolute value. That's the first one in row 2. Let's do this one. On your own. Go for it. And compare it with your neighbor. Compare with your neighbor.
Yeah, that is. Okay, so you
I didn't make it. This went down. So I assume that's good. It's opposite.
Okay.
It's not the
Here we go. Boom. Raise your hand if you have the -3 right. No. This is 3 times as tall. Not 1/3 as tall. It's 3 times as tall. Okay. Raise your hand if you had the -6 right. Okay, good. Raise your hand if you had the +5 right. Okay. So that vertical stretch, it's times 3. Or find your slope of the right side. My slope of the right side is 3. I'm sorry, -3. Okay. If my slope is a fraction. Because, like this one, if I go for my vertex, it's down 3 over 1. So my slope is just down 3 over 1. Okay. Now, the toughest part of all of this is when they are parabolas. But I just kind of realized something. But anyway. So this one right here. Let's do the 2 on the top and then the rest. Let's see. We got 1, 2. We're going to do 3 more. So here my vertex is 3, 9. I'll save you the troubles of counting. So we need the y equals x minus 3 squared plus 9. That part's pretty straightforward. Now I just need to decide what my factor is out front. I'm going to give you 2 different ways to do this. Well, first of all, it's going to be positive or negative. It's going to be negative. How do we know? Going down. So it's going to be negative. So now what we've got to think about is our traditional one that we do. The parent function is usually over 1 and down 1. This one is over 1 and down 2. So it's twice as big. Yeah. I'm going to show you a way we could do this that always works. So if you ever get confused what my A is going to be out front, here's what you could do. Okay? This point right here is 3, 7, or 4, 7. Okay? And I'm going to pretend like I don't know what that is. But I know it's got to be x minus 3 squared plus 9. That part's pretty straightforward. Seems like you guys picked that up really well. Okay? So now what I'm going to do is this A. What this A does is it stretches it and shrinks it. It goes like this, until it goes through that point. So I want it to go through 4, 7. 4 is my x. And 7 is my y. So what did I do there? All I did was plug in 4 for x and 7 for y. That's all I did. And now I can solve for a. It'll tell me, the algebra will tell me what a is. So let's go ahead and let's subtract my 9. Negative 2 equals 1 squared a. So just 1a. So a is negative 2. It'll tell us, yes, it's got to open down, and yes, it's going to have a stretch factor of 2. That will always work. So if you like that, you can use it. If you like the algebra side rather than, let's kind of just make it so it goes like this over here and goes down 2 instead of down 1, you can just use your algebra if you want. You can do it either way. Okay? So like on this one, I've set this up for us to do this one instead. Do that using that second method. Let's go ahead and write my deal. My vertex here is negative 5, 3. And let's say one of the points that I'm going to use is 1, 7. So let's write what we know. So now what could I do? Plug in 1 for x. Okay, something feels wrong. No, we're fine. So all I did was I plugged in 1 for x, 7 for y. Now we solve it. 6 squared is 36. Sorry. So you could do it that way if you want. That'll work. It'll work every time. But if you want to use what we were doing yesterday, there's going to be a different answer that I would accept in this case. I'm going to leave that there for just a second. Bless you. Okay, here's another way we could attack this. We could say I've got a y, and this isn't going to be technically correct, so any people that are watching this online out there, yes, I know this is technically incorrect, but I don't want to open a whole big can of worms on something. I could go x squared plus 3 plus 5, but then I need a multiplier here, and I should have left room for that. Gosh dang it. Usually, we go out 1, up 1. This one we went out 3, out, up 1. So it's been stretched by 3 horizontally. What multiplier out front, inside, would yield stretch by 3? No flip.
1/3.
1/3, because that's kind of the opposite multiplication wise. So I would also accept that. I know that's not written very clearly. My apologies. And technically it would have to be like this, but don't worry about it, Okay. So let's practice a horizontal stretching and shrinking on this one right here. One-third. Because bless you, remember, to figure out what's going to do horizontally, it's the opposite of one-third multiplicatively. So it's going to be 3 times as wide. Okay, so let's do this y equals 1/3 x squared. I'll zoom in here a little bit so we can get a little bit more clearer. Okay, let's plot my original. So what's going to happen with this 1/3? What's it going to do? Yeah, it's a horizontal. It's going to make it the reciprocal of 1/3, so 3 times as wide. So now instead of going out 1, up 1, I'm going to go out 3, up 1. Instead of going out 2, up 4, I'm going to go out 6, up 4. And you'll see that it gives me something that it looks like it's been stretched horizontally. I took the orange and I went, stretched it out horizontally. Okay. So here's what I want to do tonight. The rest of the time is going to be yours. Everything that we didn't do on that worksheet, I want you to do. So there's 5 problems there. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 from the book. I don't think you're going to have to graph anything. So 5 from the worksheet. Those from the book. Use your time wisely. And you got about 12 minutes. I could do that. Ooh, I could.